I'm Adam from RFOXiA. From our real lab today we are answering this: how does a power system charge completely in 5 minutes and then run your hardware for a full day? The conventional answer to the power problem in field electronics is a lithium battery. You charge it overnight, it runs for a few hours, you charge it again. That cycle is so familiar that most people stopped questioning it. I want to question it. The Multi-Nav Pro Plus Power Kit uses a supercapacitor system, 1100 farads, storing 8,800 joules of energy, charging fully in under 5 minutes, powering the complete Multi-Nav Pro Plus module stack for 24 hours. The moment I describe those numbers together, most engineers I talk to pause. The pause is because those numbers seem contradictory. Fast charge and long runtime feel like they should be in opposition. They are not. But understanding why requires going back to what charge time and energy capacity actually are separately. Let us start with the battery. A lithium cell stores energy electrochemically. When you charge it, you are driving a chemical reaction, lithium ions moving through an electrolyte, intercalating into electrode material. That reaction has a speed limit. You cannot simply increase voltage and current without limits, because beyond certain rates the chemistry becomes unstable. Lithium plating, thermal runaway, cell degradation. This is why your phone takes 2 hours to charge even with a fast charger. The fast charger is already pushing the edge of what the chemistry tolerates. A supercapacitor stores energy differently. There is no electrochemical reaction. Energy is stored as an electrostatic field. Charge accumulates on electrode surfaces separated by a very thin dielectric or electrolyte layer. There is no chemistry to destabilize. The limiting factor on charge rate is purely electrical, the resistance of the circuit. Lower resistance, faster charge. This is why the kit charges at 4 volts and 10 amps, 40 watts into the system, and completes in under 5 minutes. The capacitor does not care. It is just accumulating charge on a surface. Now the energy question. A farad is a unit of capacitance. Specifically, it is 1 coulomb of charge per volt. 1100 farads means that at 4 volts, this system holds 4,400 coulombs of charge. Energy stored in a capacitor is 1/2 times capacitance times voltage squared. Half of 1100 times 16 is 8,800 joules. That is the number, 8,800 joules. Now let us convert that into something useful. 1 watt hour is 3,600 joules. 8,800 joules divided by 3,600 gives you approximately 2.4 watt hours. The complete Multi-Nav Pro Plus module stack, BLE module, GNSS module, sensors module, draws roughly 100 milliwatts under typical operating conditions. 2.4 watt hours divided by 0.1 watts is 24 hours. The math is not approximate, it is exact. The 5-minute charge claim and the 24-hour runtime claim are both direct consequences of the same set of physical numbers. Neither one is marketing. I want to address the thing people say next, which is, if supercapacitors are this good, why does every consumer device still use lithium batteries? The answer is energy density. By weight and by volume, a lithium cell stores significantly more energy than a supercapacitor of the same size. A supercapacitor that stores 2.4 watt hours weighs considerably more and occupies more space than a lithium cell with the same capacity. For a smartphone that needs 15 watt hours in a thin pocket device, supercapacitors are not the right tool. For a field electronics module stack that needs 2.4 watt hours and benefits enormously from 5-minute recharge and no battery degradation over thousands of cycles, the supercapacitor is precisely the right tool. This is the part of engineering I find genuinely interesting. The question is never which component is better in the abstract. The question is which component is better for this specific constraint set. When your constraint is charge speed in the field and that is the physics, electrostatics, not electrochemistry, charge rate limited by resistance, not by reaction kinetics. Now let me show you the actual hardware. This is the supercapacitor bank itself, 1100 farads, 8,800 joules stored at 4 volts. The key thing to understand looking at this component is that none of the energy in here is being held by a chemical reaction. It is purely electrostatic, charge sitting on surfaces. That is why it can release and accept energy as fast as the circuit resistance allows. There is nothing here waiting for a reaction to complete. This is the charging adapter, 12 volts 5 amps input stepping down internally to 4 volts at 10 amps for the capacitor bank, 40 watts in under 5 minutes to full capacity. The reason this works without damaging the capacitor is that supercapacitors have no charge rate chemistry to destabilize. You are not forcing ions through an electrolyte, you are moving electrons onto a surface. The physics cooperates. This is what full day runtime looks like in practice. The complete Multinav Pro Plus stack, BLE module, GNSS, sensors, drawing approximately 100 milliwatts continuously. 2.4 watt hours divided by 100 milliwatts is 24 hours. That calculation is not an estimate. The capacitance, the voltage, the draw rate, and the runtime are all related by the same equations. The numbers mean what they say. This is the Slink programmer included in the kit. Once your hardware is in the field, firmware updates and debugging need to be straightforward. The Slink interfaces directly with the BLE module and gives you full programming access. Write new firmware, inspect registers, debug live. In a system where the power supply no longer forces you to stop working, the last thing you want is a programming interface that does. This is the complete connectivity kit, all cables included, flat ribbon cables for connecting the BLE module to the power board and the programmer to the module. The physical connection between components is part of the system design, not an afterthought. Flat ribbon cable means low profile installation in enclosures, drones, or any platform where routing matters. Everything you need to run the full stack is in the box. 5 amps from the included adapter, which steps down internally to 4 volts at 10 amps for the capacitor bank. Full charge in under 5 minutes, no memory effect, no degradation from partial charge cycles, no fire risk from overcharge, and after 24 hours of running your full module stack, you connect the adapter for 5 minutes and you are back at full capacity. The Multinav Pro Plus Power Kit eliminates the dead battery excuse so completely that you will have to find a different reason to stop working.